Can you hear me? Yeah, you can hear me. Awesome. Yeah, so thanks for having me. You know, I and some of my colleagues live in Austria. And when you think about Austria, you very likely think about several things like nature. We have the mountains there, we have nature, it's really nice. Some people also think about skiing. However, there is another topic that is a bit more serious, and normally we don't talk about it that much, but it's on everyone's mind. It's Sacher cake. Yeah. It's one of those desserts we have there, and we have also further desserts. And this is what this closing keynote is about. It's about Austrian desserts, but also about other things in the space of signals, things like computed signals or rendering effects and business effects. We talk about RxJS interop and stores. So the result of all of this will be 3 rules of thumb that help you to use signals in a safer way, and also 3 hints that help you when using signals. Before I start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and together with my colleagues at Angular Architects, we are helping companies with Angular in the enterprise. In this role, we are doing a lot of consulting and reviews and also trainings and workshops. Besides this, I'm quite connected to the Angular community. I live in Austria. This is where we have Sacher cake, as you know. But I also do a lot of stuff in Germany, the Switzerland, and other parts of the world. I'm always happy to work together with people around the globe, for instance, with people in Bella, Italia. Awesome. So let's get started with the most important topic of the whole day, of the whole week, of the whole month. It's Austrian desserts. So the thing is, we created a sample application that is complex enough to show everything we want to discuss. And this application is about desserts we have in Austria. Here we have Sacher cake, the original name is Sachertorte, Apfelstrudel, Palatschinken, and so on, and you can rate them. And if you say, well, for ice palatschinken, which is by far the best dessert we have, ice cream pancakes, 5 stars are not enough, then there is a cheat mode. Just double-click the star here, and you can give it up to 500 stars. 500 stars out of 5 stars when it comes to ice cream pancakes. Mathematics does not matter anymore. Besides this, we can search by the original name, like palatschinke, or by the English name, and we can load expert ratings. Those are the ratings from me, and those are the ratings people might want to respect when coming to Austria. Yeah, this is our sample application. And now let's use it to discuss several aspects of signals from an architectural standpoint. The first topic is perhaps the most underrated topic in the area of signals. It's computed signals. Le signale computate, I think, is the English term for it. I hope I pronounced it somehow correctly. So let's have a look into it. So what we see here is my desserts component, and we see it's already signal based. I have a signal for the original name, I have a signal for the English name, those are my filters. There is a signal for the loading flag and a signal for my loaded desserts. And so far, it's really quite easy and straightforward. However, if we scroll down to loading the expert ratings, we see, well, I'm asking the service to load the expert ratings. And then, when I got those ratings, I squeeze them into my already loaded desserts. This helper method do rated squeezes them together, and the result is my rated desserts, and I'm just overwriting the original desserts with them. And yes, this works. This is doable that way. However, it's a bit special, isn't it? Because after all, we are talking about ratings, and nevertheless, at the end, I'm updating not ratings, but desserts. And if we need to remember to update desserts here and there and on 5 further locations, we might miss some of them. And then the UI will behave somehow strangely. So let's have a look into a better solution I have implemented with signals and computed signals. Look here. Here I have my desert signal. I have my ratings. It's also a signal. And then I have my rated deserts. And the good thing is, rated deserts is just computed out of the former two. It's computed out of deserts and rating. For this I'm calling computed, which comes from Angular core. I'm calling do rated, and I'm passing in deserts and ratings. And this assures that this computed rated desert signal is always up to date. It's always up to date. When this or that ingoing signal is changing, it will be recomputed. The full story is it will be recomputed lazily. So if no one is using it, it won't be recomputed. But if someone is using it, then you get automatically the actual value, the new value. And that's great, because now we don't have to think anymore where to update this, where to update that. Plus, we get our view model, the model that is needed for our view, that represents the data we need in our view, calculated when we need it. This streamlines the code a lot. Okay, cool. Let's go one step further. Let's talk about the first architectural rule we can derive from this. The first architectural rule we can derive from this is synchronously derive state where possible. So where possible, use existing state and compute out your current state you want to go with. In this case, you will always be up to date. Let's talk about effects. And here I want to get started with rendering effects. And perhaps you are saying now, well, rendering effects, I hear this term the first time, because in Angular there is just an effect. So why does Manfred come up with rendering effects? And the story is that some days ago there was a nice discussion at GitHub, and there Alex Rickerbo from the Angular team mentioned that it would be smart to distinguish two kinds of effects. The first kind is the rendering effect, that is rendering something that cannot be done with data binding. Rendering something that cannot be done with data binding. This could be, for instance, drawing on a canvas or displaying a toast message. Usually you need to call a method for this. And then there are business effects that trigger business logic. And he argues that we need different strategies for those effects. However, the current effect implementation in Angular is mainly for rendering. So what we get out of the box is indeed a rendering effect. So let's have a look into rendering effects, how they look alike, and what we should avoid in there. So let me grab this branch name. Let me jump over. Oh, come on. Come. Yeah. Oh, it's jumping back, so it's reluctant. Now we are talking. Okay, cool. So what do we have here? If we look into our deserts component, then we see here two typical rendering effects. They do something we cannot do with data binding. In this case, it's locking out something to the JavaScript console or displaying a toast message with XYZ deserts have been loaded. This is for what effects have been intended for. This is what Angular team had in mind when defining effects. But besides this, you could have the idea to write an effect that is just delegating some data to some service. Let's say I have my service here, and I want to do the service things, so do stuff. And here perhaps I'm passing in my deserts or some criterias so that something happens. Of course, also this effect would run, let's scroll it up. Also this effect would run time and again when this.deserts is changing, but this has a lot of consequences. This is not what they have been intended for. Because if we write code like this, we have the situation that we change something here, and this change leads to another change, that leads to another change, that leads to another change, and if we have bad luck, it leads to the first change. And this is then a cycle and something that is not necessarily a good idea for performance, and it's also not necessarily a good idea when it comes to maintainability. So for this very situation, we need something else. Come on. We need something else, and this leads me to my second rule, which is avoid rendering effects propagating state and signal rights. Because you can end up with cycles or just several effects that occur in a row and that are not maintainable anymore. So now let's also talk about business effects. So what are business effects? As mentioned before, those are effects triggering business logic on signal change. And they are somewhat critical, because we have already discussed the idea before that we get loops and cycles, but there is another reason. We have this glitch-free property when it comes to signals. Who has heard about the glitch-free property? Some of you. It's basically that if I change a signal several times a row, every change will get lost but the last one. The effect will only see the last one. And this is done by intention. This is done by intention. We don't want to deal with intermediate values, because if I would start rendering intermediate values, I would do a lot of effort that is not necessary. So all intermediate values that happen in a row are discarded, and only the last value is taken. Most of the times this is okay-ish. However, when we need real eventing, then we cannot take signals for that reason. If we need real eventing, where each and every event is respected, signals are not the right solution. This is one reason why signals as events for business logic might be an issue. The other issue is that this all leads quickly to effects writing signals, and this in turn might quickly lead to change of change. One change leads to another one, and that leads to a third one, and so we could end up with cycles. So this is the issue here. Some people propose an alternative to this, and this alternative seems to be simple at first glance. It's just using the event behind the signal change. Don't use the effect, don't use the signal, use the event behind it. What does this mean? Well, let's say we have an event, a click event or a data event where the HTTP client says, hey, I have new data for you. In this case, we could change a signal via the event handler, and via an effect, we could trigger some business logic. But instead, we could also use this event directly to update the signal and pass this very value to the business logic. So in this case, we don't need an effect anymore to trigger our business logic. That really looks nice at first glance. However, it's not the last word on this. It's not the last word on this, because the Angular APIs are more and more signal-based. That means we get more and more signals we for sure want to use. And sometimes it feels just unnatural to use the events behind the signal when the signal is already providing what we need, more or less. Let me show you an example. Let's say you have an input, and let's say you have already data bound your signal, or in this case it's my signal. And you see it's a two-way data binding. So we can already find out via the binding when our signal is changing. And in this case, it would feel quite unnatural to set up a change event just to bypass reading the signal, just to bypass reacting on signal changes. And that means we need a better solution for this very space. And for this I have prepared another demonstration. So for some reason my bar here is locked. No, now it should work. That's good. So let's copy this one. Yeah, now everything works again. And let's jump into this version of our solution. It's still about deserts, but now we get a button detail. And this button leads to something I'm calling UI for humble people. UI for humble people. It looks like this. And yeah, you can scroll through, or let's say page through all my records. And every time I'm changing the desert to display, a new value ends up in my root. And every time a new value ends up in the root, the router will synchronize this root value, this root parameter, with my desert detail component. So it's here. So I'm getting down the ID of the desert to display. This is already one of those new signal-based inputs. And that means I need to react on the change in the ID. And a very simple solution for this is just going with Angion changes. This is straightforward, just going with Angion changes. However, when we talk about signal components, there won't be an Angion changes. In signal components, we don't have this lifecycle hook anymore. And so in the future, when those signal components arrive, we need a more reactive way on doing the same. So a first idea could be to set up an effect. And this effect could now do what before Angion changes did. So looks somehow nice at first glance, but let's try it out. Here we already see garbage. This is my null object, so no meaningful values in there. And if we go to the console, we see, oh, writing those signals is not allowed. So for some reason, we see here that we try to write into a signal. And now the first question is, where do we write a signal? There is no signal write, isn't it? Well, the truth is, the signal write happens in there, within the effect. Within the effect, at some stage, we will see something like, let's write the desert signal. Let's write the loaded desert into it. Of course, we need to put the desert somewhere we can then find it. And this load method will do this. And funnily, this effect, as a so-called implicit effect, will also find out about this setter call. And so it will see, well, you are writing into a signal, this is not allowed. By the way, it will be allowed in the future. This restriction will be removed. However, it does not solve the issue, because if an effect writes in a signal, another effect could write the same value in the same signal, and so on and so forth. But it's even more severe. We also have signal reads in there. Perhaps we are reading the loading signal. And also here, this effect in Angular is currently implicit. That means it will also detect this call to loading inside of load and will subscribe to it. And so every time loading is changed, the whole effect will be retriggered. And this is for sure nothing you want to have. And now we have another reason why those business effects are really dangerous. So what can we do about it? Well, one solution would be to introduce untracked. Which means more or less effect, leave my call to store load alone. Just ignore it, just look at this here, and every time this here is changing, retrigger that. But don't listen on stuff within load. So this is for sure a pattern that is used a lot. Another approach could be to put all of this into a helper function. In my case, it's explicit effect. Here I'm just passing in my signal, and we are watching just this signal. And every time the signal changes, this here will be executed in an untracked way. Another solution. However, this solution with untracked is also used by the RxJS interop, by NGRX and the Signal Store, and by a lot of other community projects out there. So it's really a thing. It's not the most beautiful pattern, but it is a thing. And saying this, of course, you could also use the RxJS interop to work with all of this. Here I'm directly subscribing, but in the real world, perhaps you want to set up a reactive chain that flows from the start to the end result you want to display. Or if you look into the new Signal Store, then you have something like reactive methods. And when it comes to reactive methods, you can put a signal to them. Those reactive methods will subscribe to the signal and rerun every time something in this very signal is changing. So this would also be a nice solution. And I think that shows that we need something else, some support for those business effects when we want to go with them. And this leads to a hint. Be aware of options and consequences of business effects. Be aware of it. I don't say don't do it because that's not possible, but be aware of it. Talking about this, let's also talk slightly about the RxJS interop. And here I start with my next hint. Signals play well together with RxJS. There is this interop, and so we can have the best of both worlds. For instance, all those powerful operators like the bounce time or switch map, stuff you don't want to do by hand. Plus, RxJS can take care of overlapping requests and race conditions. So let's say we are searching for pancakes, and before we get the result, we search for Sacher cake, and before we get the result, we search for ice cream pancakes. Normally, we would just expect the result for ice cream pancakes. We don't expect that we get the other results that are correlating with already changed filters. And it might be even worse if the system does not respect this. And if one of the tasks take a bit longer, then we might have this race condition where the results come up in a different order than our requests. RxJS makes it really easy to deal with all of them. For this, RxJS gives us those flattening operators like switch map and exhaust map. In this very case, very likely, switch map is the way to go. This brings me to another hint. Avoid race conditions. Think about race conditions somehow by using RxJS or by using a loading flag that displays a loading indicator and so prevents that someone clicks the search button again. And last but not least, I want to talk about stores, because if you ask me, stores are the missing link in the whole Signal story. Because without a store, your application ends up as an incredible machine. La macchina incredibile, the incredible machine. You see, the idea of this was to trigger a side effect. One side effect leads to another side effect, and so on and so forth. And this is for sure a nice game, but this is nothing you want to have in your application, because then your application is not maintainable anymore. And to prevent this situation, we can go with a store and something like unidirectional data flow. We have this intention on the left side. The intention is an abstract verb because it depends on your store how this intention looks like. When we talk Redux, this intention is an action we are sending over. If we talk about a lightweight store, this intention is just a method we are calling. Then within the store, we have some actions that take place, like synchronous actions or asynchronous actions. This is something signals cannot do. Signals are not intended for asynchronous stuff. And then on the right side, our data flows down from the store to the component. The new data we got from the asynchronous action flows down into the component. And for this, we could also use computed signals, as mentioned before, to get the structure we need. And interestingly, the right side is the main use case for signals as they have been intended originally. So on the right side, your signals live. On the other side, the signals don't have that much meaning. Sometimes on the left side, they can be used for business effects. We have just discussed that. But they can also be used for, or instead of this, we could also use events or RxJS. And in the middle, we have the asynchronous actions that can also not be done by signals. So we need to offload them to a store and or do RxJS. Since I keep this here in mind, my life with signals is far easier. And this brings me to my last architectural rule, and this rule is stores make your reactive flow more manageable. By the way, if you like all those ideas, we have this free ebook. You can download it here, and you find such ideas and much further ideas. And now, as this is such a nice happy today, I want to welcome my friend and colleague Rainer Hahnekamp here on stage, who has prepared more examples and some experiences.
Thank you.
Wenn du das brauchst.
1, 2, 3.
Liegt gut. Passt.
So, microphone is working? Okay, now it's better. So, buonasera, or whatever what the right pronunciation is all about. In the last 13 minutes, I am going to explain something we did in a project. So I had the opportunity and the luck to be part of a project at an insurance company. And what they had, an existing Angular application, which was based on the NGRX Global Store, and it was built before Angular 14. So everything about RxJS and nothing else. And they told me, and they said, well, we are now in a position where we can modernize the application, and we also now have the time, but later not. So what we want to do now, if we are going to modernize it, we really need to know what we should do with those signals, because they heard, of course, of them, and they said, how does this work together with signals, with RxJS? When should we use them? What's the right balance, and so forth? And as you have heard before from Manfred, there are different rules. And, well, I said, I can't really tell anything about the future of Angular, but I can only listen or read about the statements that the Angular team has done in the past, and we can try to adopt then to that. So what we saw some kind of statements which came from Angular itself. I have listed some here. And the first statement is from Jeremy Elborn, who is the Angular tech lead. So he's quite a lot to say. And he said in September last year that they are going to plan to make RxJS optional. So this is already where the discussion with RxJS actually was initiated. And he said this, interestingly, as an answer to a question, I want to have observables for an input. And he said, no, it's not going to be an observable. You will get a signal. And by the way, we will make RxJS optional. This caused a lot of question marks. Then later, Minko Getchev, who's the Angular product lead, also clarified it a little bit. He was asked, why are you doing that? And he said, well, in the end, it's all about improving or shortening the critical learning path. So it should not be necessary, and that's the goal, that somebody who wants to write an Angular application absolutely has to know about RxJS and how it works. This was then later clarified by another Angular team member, by Pavel Kozlovsky. And what he said, and this is very interesting, because this applied exactly to this insurance company that I was mentioning before. He said, there are two groups in Angular, 50-50. The one group has reactive systems, they want more RxJS. The other group says, We have an Angular application. What do we do with it? We load data, we send it back to the backend. All these RxJS, it's extremely powerful, but we don't need it. And he said, and for this group, there also needs to be an answer. And making RxJS optional, so giving those the opportunity to use RxJS where it is required, and leaving it out for those who don't need it might be a good path. And even later, that was then also then again clarified by Minko Getchev, and that's now the last slide, where he said, even for managing asynchronous data flow, it's not explicitly required, or as it says here, strictly necessary to use RxJS. So with this information, we said it looks like we should try, first of all, to go with signals first, as long as we can. And in those situations where we see signals don't help us anymore, that we then try it out with RxJS. And we did a project on this, and we tried to apply the 3 rules that we heard before. And I want to now quickly share the experience that we had, and especially the kind of patterns that were always reoccurring that we always had to face. Because it's quite similar, it shows up very often. So I have here my third application again. This time it's a little bit extended. So we also have here a country. So I can also, for example, click here on country Italy. And if I click on search, then I get the desserts from Italy. At least the desserts that ChatGPT says. I'm not sure, but I hope it's correct. So looking at our code, what will we have? So we have here one dessert component. And as you see here, this looks very small one, doesn't have that much code, because most of the code has already been extracted into the dessert store. So that's the one which is responsible for doing all the logic, also the UI logic. And if we look what we're doing here, well, we have a filter. So we are using here the template-driven forms. And once I click on search, this function here, this method is called, and we have here a search method. And as you see here, we are using here an observable already. This is the way how it has been done in the past for many years. And this was the first question. Do we really have to go with an observable in that case? The way as it stands here, I don't have any race condition. I'm not doing anything with this observable. I just say it's a one-time request. Send a request to the backend, give me a data back, and then I just put it into the signal. That's everything I do. I don't kind of do more with this observable. And that's why in this case, we said, okay, if it's really about using signals as often as possible, what would happen if I go to my dessert service and I say find, which returns me now an observable and a promise in this case, and I would just say, I go to my desserts, to my signal, use here and await, and mark this function as async. Has something changed now? So if I now go back to my application, and I click here again on the Italian desserts, it's just working. So in my case, it's the same thing again. It has the same functionality, but again, because nobody used the observable, made use of the possibilities of the observable. And that's why in this case, we said, okay, in this case, we go with promises. Why not? You heard before about the derived state. So especially when it's a synchronous one, what you absolutely should not do, for example, when you are using now an effect, we have here a count of the search results. So what you should not do is that you, for example, say in your template, if you want to use it, then I say here, okay, P, and I say count, whatever, dessert store, and I say here I'm going to access it. And of course, now I want to update the count, because if I now search, the count is not the correct one. Don't do what I'm doing now, that you create a count effect and say, well, I have now an effect. What I want to do, my effect should now track my desserts, the signal of desserts, and I'm assigning it to that. This is the main pitfall or the main error that you can make with an effect. Don't do this. This is just a typical example for a computed, and I would say this is also what the Angular team is warning us all the time. Don't use an effect if you can do the same thing with the computed. In this case, it's obvious, but as you know, applications tend to be a little bit more complicated than just a few lines of code. Always look out for an opportunity to avoid an effect and go with the computed. So I'm going to change this. I'm going to say, okay, the count now becomes a computed, and I say this, desserts, I'm going to track it. Length, I'm going back to my component, I'm calling here the signal, and that's the way how you do it. So if I now again say Italy, we see it's working. So back to this observable promise thing. So as I said before, the way how it was implemented, it didn't really matter if I use a promise or an observable. Manfred mentioned before racing conditions or kind of coming up with a loading flag. What does that mean? If, for example, we say here, I'm going to reload my site, and let's say I click on Italy. So I click then here on search. Then I say Austria. I click on search again, and then I immediately change my mind and click again on Italy. Now we have here an Italy in the country, and we see maybe not the Italian desserts, the Austrian ones. What I have here is the typical racing condition. So it happened that the request for the Austrian desserts took quite much longer than their last one, and that's why the Austrian ended up being shown here. And if you say, hey, this is something where I have to be a little bit careful, you might not immediately have to jump to RxJS. Of course, it always depends. But when you want to use a loading flag, and you say this is acceptable in my case, then it would look like this. Your dessert store would have to say, I will have a loading state. So I need to know when I'm loading my data. So I'm going to implement now here loading. So I say here that's a signal. And at the moment, I'm not going to load anything. And I'm exposing the loading via this loading as read-only. This is what I do. And then I say when my dessert store gets now the command to search, I'm protecting it in TypeScript. I say, well, if we are currently loading, then it's already over. I will continue anymore, then I'm just returning. But if not, then I'm saying, okay, loading, I'm now going to load. And once this is done, I'm setting the loading flag back to false. So this is the typical pattern when you say you can kind of manage it via loading flag or via the UI. The UI implementation is now missing. What I have to do, because our users also need to know what's going on, they need to understand that currently the request is loading. It's very simple. So I say here disabled. In this case, I'm disabling the button. And I say, okay, this depends on my dessert store. If it's loading, then please disable it. And if I want to be a little bit more user-friendly, then I would say, okay, dessert store, I'm loading. If this is the case, then I'm saying here searching ... And if that's not the case, then I say here search. So my users now immediately know what's going to happen or what is the current state. And they do understand that they cannot click on the search button if the search is currently in progress. So again, I say here, okay, I click on Italy, I click on search. That one was a little bit fast. Then I click on the Austrian one. That one will take 2.5 seconds. And this is now what happens. So in my case, the form is blocking, but also the submit button is blocking. And if you say, this is everything that I need, I don't have a more complicated use case than that one. Remember, this is what Pavel said. Very simple applications that just fetch data, have a submit button, and send it back. And this is what you actually can end up with. You might not need observables for that. But if, and now I'm going to switch over to the solution branch because it's just 1.5 minutes left. But if you now say, hey, we have a little bit more there. It's not just like clicking on a button. We have here a reactive form. So maybe I want to use the value changes from the ng form. I want to use a debounce time. I want to say while the user is clicking or typing something in, I want to use a debounce time with 500 milliseconds. Then I will start my request. I will use a switch map for it because I need to have a cancellation of the HTTP request. So all the good stuff, which is a little bit more complicated, but still if the UI requires it, then it's point in time to switch over to the reactive stuff. And as I said, I'm going to revert it. And I have my Rainer solution. And then we just take a look at it. And what I've done here is that now our dessert store has changed the search method completely. Because what I'm doing here, let me open the dessert component. It still has a search, but here we are using an effect. So the search says, well, I am going here to my view child or here to the filter, and I want to kind of run an effect on it. But in this case, it doesn't really make any sense. Oh, it does make sense because the filter is provided. So I use here something which Manfred before defined as the business effect. So I really say I need to use the untracked. I'm not tracking anything at the moment. What I'm doing here is that I'm passing on the signal itself to the service, to the store. Why I'm doing this? Because the store in this case, it is a dessert store. It is made only for the component. It's not a generic service. And therefore, also the store can deal with this reactivity of it. And I've been using already this RX method, which is a shortcut, which just makes it a little bit more easier for you to understand. But what it does, that the dessert service here just needs to consume the observable of the value changes. As you see here, we have our debounce time, we have the tab, we have the switch map, then it does a subscription and writes the data back into our signals. So we end up still having signals in the component. They are there for the rendering part, but where it is necessary in the service and the logic layer, we are going to use RxJS in this case. Last few sentences. Our main concern during the project was not that. That was easy. These are common patterns. Our main concern was dependencies to a signal. So if I need to run a side effect on a change of a signal, what are we going to do? Because the signal has the glitch-free effect. Is it really a problem if the signal drops some events and we are not aware of them? And we have been using the signal store extensively. We have replaced the signal store, we have replaced NGRX Global Store with the signal store, so there are a lot of dependencies in there. And what I can say by now is that the glitch-free effect didn't really cause us any troubles. So we could also use a signal as a source of an event, we could misuse a signal as an event, and it worked for the most cases. If you want to know more about the discussion using a signal as an event, there is currently a very nice RFC at the NGRX Signal Store. It's an RFC about introducing events back again into the Signal Store as an output, and there you have a list of all the pros and cons. But for us, signals also worked as a mechanism to simulate events, and glitch-free was not that much of a problem. So this is what I can say from our experience. And by that, yeah, thank you very much.